Hello. In this video, we are going to look at the second week of two-year Algebra 2A, Unit 1, SLT 2, given graphs of relations, determine the inverse relation using symmetry, and SLT 3, determine connections among symbolic, graphic, and numeric representation of inverse relations. As we mentioned in the previous video, in the previous SLT, on a graph, inverse functions will have the reversed x and y values. So here you see x, y values for an original function, and they are reversed for the inverse function. As an example, point -1, -2 is on the original function, and point -2, -1 is on the inverse function. The graph to the right shows the linear graphs for the points in slide 2. The original function is y equals 3x plus 1, and the inverse function is y equals x minus 1 divided by 3. The dotted line is the line y equals x. What you may notice is that the line y equals x acts as a mirror to have a reflection of the original function and the inverse function. And so with graphs, an original function will be a reflection over the line y equals x of the graph of the inverse function. Here's another example to show you how functions and their inverses look on a graph. The blue line represents the equation y equals 2x plus 3, and the red line represents its inverse, y equals x minus 3 divided by 2. The green line is the line y equals x, which acts as a mirror between the original function and the inverse function. So, in summing up, there are three ways to examine inverse relationships. One is algebraically. You can work backwards in the instructions to find the inverse equation or relation of an original function. Two, you can look at points on a table. The xy values for a given equation would be the points yx on the inverse of the equation. And three, graphically. The graph of an equation will be the reflection of the line y equals x of the graph of the inverse of the equation. Thank you for watching this video, and we hope that it helps summarize material for two-year Algebra 2, Week 2.